Hello everyone. Today's video is based on designing another system for displaying some 7-segment display operation using LED lights. Okay, so we are going to display some alphabets basically using LED lights organization. Some LED lights we are going to just connect, and then we are going to write a code where we are going to display some alphabets in an array format. We can assign a function called array. We can also define array size, something like that. And let's say we are going to display 15 numbers or 15 alphabets, or maybe 2 alphabets or 3 alphabets. We can modify our code accordingly. Okay, so for this system we need to know, those who have forgotten or you don't remember, we need to know how a 7-segment display actually works like. Okay, and what was your 7-segment display actually in a hardware system, if you think how many modes of operation are there. So basically 2 types of 7-segment display is available. One is cathode, another is anode. Okay, anode, common anode and common cathode. So common cathode is for ground connection. Okay, common ground connection is there, and common anode is when you have common VCC voltage supply. And notice carefully, inside each and every 7-segment lights. Okay, these are basically the lights. Okay, 7-segment comes from the name of 7-segment display actually comes from how many lights are there. You can see A, B, C, D, E, F, G, which means in total 7 lights are there. But along with that, if you want to display one full stop for any reason, then you can take 8 lights also. But since this light, dual input line light it is called. Okay, this is dual input line package. This is basically for one light system if you want to show a full stop after showing cascading some 7-segment displays, and just showing 1 or 2 full stops after just showing one sentence or something like that. Okay, if you need, but firstly you need to know how a 7-segment display works. So the basics will not be discussed in this video by me. It is actually, the basics are for previous courses, because today's our main objective is to understand how this operation can work, and how proteus you're going to operate proteus. Instead of doing any visual designer like flowchart orientation, okay, instead of drawing any flowchart, we are going to write one code system so that it works effectively. So before I show you the process, this is basically the folder, or you may say one system I have designed. So I have saved this file actually. So I will just play it so that you can see what the transition is, what is our main objective for today. Okay, how after how many time, okay, 1 second delay, after 1 second delay your next alphabet will show, etc, etc, if you want to, or maybe you can delay the time as well in your code. So anyways, let's see. So this is A, showing A. Next is showing B. You can see small b, right? Next is C. Okay, capital C. Next is capital small c. Okay, lowercase c. Then lowercase d. Then E. Okay, E. Then is capital F. That was capital E, the previous one, capital F. Next is capital H. Okay, uppercase H. And then lowercase h, or small h. Next is capital L. Okay, next is I. Next is 0, or you may say O. Okay, capital O. Next is small o, small letter O, case sensitive, which means if you think lowercase. Okay, next is lowercase uppercase p, capital S. Okay, capital P, and then the last one was capital S. So again, since it is a loop work, it will go on and on, like A again showing, B again showing. Okay, this is how it will operate up to capital S, just the same string. Why? Because inside our code we have used 15. If you count all the alphabets, you will see it is of 15 different alphabets. So now let's stop this simulation for a moment and try to understand how your circuit, you are going to make your circuit first, because before writing any code work, it's better to build the circuit first to avoid any sort of mistake. So how you can do that? You can go to pick device. Okay, I have taken yellow color for now, but you can take some other color also. So how you are going to find LED lights? So you will just write LED. Okay, so if you scroll a bit, just go to pick devices and you can scroll from here the list. Okay, how many different sorts of LED lights are there? You can see there is blue, green, red, yellow. Yellow is the most prominent one, but the second one is green color. So you can select any light you want, just take it and place it. Okay, so you need 8 different lights here. So here already 8, not 8 actually, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 14. Okay, for 7 segment, which means for each segment, for representing a light, okay, a segment, you need 2 LED lights. For representing B segment, you need another 2 LED lights. So you can redesign your system. Instead of taking 2 lights, you can take 1 LED light also. So that can also be, you can modify that afterwards as well. Okay, so now since we are doing this way, we can take how many LED lights? 8 LED lights. Arbitrarily you will just take it, and after that just make the connection, these two for pin for showing the light from 7 segment as G, these two for showing the light from 7 segment display as A. Okay, then B. So these A, B, C, D, E, F, G, you might have a question, how does this come from? This is actually coming from this one right here. Okay, 7 segment display. So here small a, small b, small c. Okay, these pins, these are basically the internal pin connections of 7 segment display. So now let's proceed towards the coding. Okay, before going to the code, you need to understand that how you're going to assign show or display the digits. Okay, display different alphabets. The application of 7 segment display is very vast. It is already used in different clock sort of operation. Okay, showing some time or showing output in numerical values. Okay, maybe in digits 1 to 0, in between 1 to 0. If you want to show any message, that can also be done using 7 segment display as well. So the operation has to be, this is not basically one basic one. You have many different 7 segment display codings already available throughout the internet. So this is another example. So it depends on you that you are going to follow this process or not. The coding style is mainly used by timer operation. We are going to use some timer functions for this system as well. So before we go into the coding, we need to see how we can display capital A. So for capital A, if we represent this in 8-bit representation through 7 segment display, you know that you have inside A, B, C, D, E, F, G. Okay, these 7 dots. Okay, 7 lights, and along with this light there is one dot light. This light is that full stop light. Okay, dual DP, that display point or dual point. Okay, that point is basically your full stop. Okay, so along with the full stop you have 8 bits, which means A, B, C, D, E, F, G, full stop. So for displaying A, let's consider you want to display A, so you know D has to be off, isn't it? So we can say A, B, C, D is off, and you are also not displaying, or you are not also turning the full stop light on as well. So since it is in off state, so we can say that this is 0. So similarly for displaying any digit, okay, any digit, let's say you want to display O, which means capital O. So for capital O, you want to display capital O, you need to turn off this G, isn't it? So just G pin, as you can see, the G1 is off, okay? A, B, C, D, E, F is high, G is off, and full stop is also off. Similarly for each and every alphabet. For C, let's try for C, capital C, okay? We have two C. So one is the capital C, another is the small c, okay? So we will try to observe the capital C case, okay? So let's observe capital C, okay? For capital C, B light, C light, and G light is off. So let's see here, we have capital C, A is high, okay? A is on, B, C is off, D, E, F is on, again G is off. So this is how you can write all for all the alphabets you want to display. So after these one is done, you need to convert it into hexadecimal representation. But before that, you need to mirror this A, B, C, D, E, F, G. Okay. So if you mirror this, what will happen? Just you need to replace all the bits. Okay. Just you are mirroring it, or you may say instead of mirroring it, you can also say you are just complementing, okay, complementing each bit, which means 0 is becoming 1, 1 is becoming 0, then 1 is again you are just, I mean, instead of writing it as it is, just mirroring it, okay, 0 0 1 1 1 1 1 0, okay, so it is becoming 0 1 1 1 1 1 0 0, okay, just mirror operation, okay, just your LSB is becoming MSB and MSB is becoming LSB, and all the serial digits are going to just be placed, all the bits are going to be placed just in mirror in XY, what is it said, okay, XY axis, okay. So if you represent that in hexadecimal, 8 bits can be represented in in group of 4, okay, in 2 parts, which means if you give a space here, it is becoming 7 and 7 0 1 1 1, already it is 7. So you can give a space in each one, you can see 7 and C, just hexadecimal representation. 3 and 9, okay, this is how 5 and 8, 5E, 7 9, this one is 7 1, okay, this is 7 6 for H. So these values, why, you might have a question why we are going to take these values, because these are the values we are going to place while defining the array size, okay. We are going to use some functions for our coding, Arduino coding, okay. So we are going to write the code inside Arduino software. So as you can see, this is how you can make one table out of it. So after this table is done, already your hexadecimal values you have, okay. So now is the turn, or now is the time, only to avoid or make the video as small as possible, I have already written the code, as you can see. So let's see what is the code actually. So I'm just zooming in a little bit so that you can see which alphabets you want to display. If you go back to the table, you have A, B, C, two types of C, okay, uppercase, lowercase, D, E, F, okay, all these are, some are lowercase and some are uppercase. So just our target would be just placing these values, these hexadecimal representations, where? In this array, display array size, in this area, okay. So now this is how you're going to write for 7 7 A digit will be shown. For 7C, B digit will be shown. This 0 cross 77, actually this 0 is responsible for defining the port D. Okay, this is the limit, actually, data direction register, DDRD. If you have read interrupts before in your course, or maybe related to Arduino, maybe you have done some experiments related to timers. Okay, or maybe you have done some coding work related to timer operation inside Arduino using Arduino microcontroller. For that, you have to use some functions, actually some register names. You need to define those initial and final values. So prescaler, the most highest prescaler is used already, from timer, if you have learned or gone through that. This is basically TCC R0B, which means count compare operation using B register, TCC timer, count control register B, TCNT timer count number register. Okay, this is counting of how many time has been passed. Okay, how many steps have been passed. So DDRD is basically the data direction register. It is used for port D, for directing port D. So this 0 is standing for this value right here, and FF is the range from 00 to final FF, which means since these values are in hexadecimal, we are going to write. So the limit is in FF. Okay, highest limit, highest value. So talking about prescaler, you already know, maybe if you have gone through the datasheet of datasheet of Arduino. In the timer section, there is one table which is named as prescaler operation. Okay, prescaler selection basically. So inside this timer, there are some chip select pins, chip select 00, chip select 02. So these two are responsible for selecting the highest or medium range prescaler, but it's advisable to use highest prescaler, because the more prescaler you're using, the better delay function you can control, okay, according to theory of timer operation. Next is this overflow enable system. So if we have any overflow in any time, so that can be also calculated or defined by this interrupt mask enable timer operation as well. Okay, so next comes while loop. How the while loop will work, we can operate one interrupt service routine for this system, and according to interrupt service routine, we can specify the overflow vector as well for timer. Since we are dealing with 8 bits, we are going to consider timer 0 for our case. And we have how much time you are going to delay. Okay, clock frequency, which means time is inversely related to frequency. You already know about it. So if you just give a count, initialize it as 0, then after incrementing, depending on how much delay you want, after how much time your next value, okay, how much seconds your next display digit or alphabet you want to show, so that can be done. And just initialize, and what is the size. Okay, so the size of the display array that we are going to use, the function that we are going to use is display array size. Okay, you already know about it. All these functions are already familiar, and since 15 alphabets we are going to use, so if you want, you can also take other numerical numbers instead of alphabets, like 1 2 3 4 5 6 etc etc. Okay, so those values can also be, one LCD display can show up to from 1 to 9 values only, because it can show one digit at a time. It cannot show more than one digit at a time. So what can be done, you need to take cascade 2 or more 7 segment displays for displaying more numbers, okay, more digits, units. Okay, for units it's fine, but for hundreds, tens, you need more display systems. Okay, so that can also be done. So now since our coding is already done, what you can do is just save it in one file name. Let's say I have saved it in sketch underscore August 25a, something like that, because I have written this code 2 days earlier. 2 days earlier, basically. Today is 27th, so this code was written on 25th August. Anyways, just make sure of one thing. For operating your overall system, what you need to do is you need to design it first. So what I was talking about was LED light, where you are going to collect your LED light using peak devices. You already have seen that. Okay, so along with that, you need to labelize your different lights, okay, different diodes. So how you can labelize that? Just go to this terminals mode. Okay, this is known as terminal mode. You can select default from here and connect it anywhere you want to connect, depending on your system. You can select ground here. Okay, ground from here. Just connect it to whichever system you want to connect the ground. Here we have used two grounds, two common grounds basically. Okay, two different circuits to make one overall system. There is no VCC because the resistors are connected to the input ports. Okay, inputs. So all these representations, so all these labels are basically your default. So if you just double click it, okay, if you just double click it, one window will come. Here you can labelize which pin you want to access. Okay, let's say I want to access IO8, for example. Okay, so that can be done. And along with that, if you want to take some resistors, you can go back to the component mode, go to pick device, write RES. Okay, RES, your resistor will come. So if you just scroll a bit, okay, if you just scroll a bit, you will get RES. This is the perfect resistor symbol. So just place OK. Since it is already available here, so I cannot again download it, so I'm not going to replace it. Okay, I'm just going to pick it from here. But initially you might not have this resistor for your design. So for those who don't have, just I have explained you how you can collect it from the list of library or devices available. So if you want to modify the value, it is in 10k, okay, 10 kilo ohm. But if you want to minimize the value, let's say 200 or 300 or 220, okay, so just write it here, 220, and then give OK. So now your resistor is of 220 ohms only. So since my design is already ready, so I'm not going to utilize the extra systems that I have added to make you understand only. So I'm just going to show you the whole design basically. So the design actually looks something like this. So after the design is being done, next target is to operate, where we are going to install this code work. Okay, how we can install a code work here. So if you select right click here in the Arduino, you will get one option, edit properties. Okay, so inside this edit properties, your file program will initially be blank. So if you go to this folder symbol that you have, then you can select in which folder your hex file is being located. But you know that Arduino is already being saved in .ino format. It is not being saved in any other name. Okay, whichever name you are going to save your file with, something .ino will be the extension always. So how you can get the hex file? If you generate your code, how you can generate that? You will go to the file option. Okay, you already know that how to verify it. Maybe some of you have worked with the hardware. So for hardware you have selected the tools, let's say, and the port number as well. But now since we are doing it in Proteus, okay, we are doing the operation in Proteus, we don't need to select any option. We will just go to file. Okay, then what you're going to do is go to this preference. Okay, preference, just select this. Here you can see the directory where your compilation, after compilation, it will be stored in some place. In usually it gets stored in app data, C users file. Okay, C drive and users file, users folder actually. And initially your compilation, this box will be crossed out. So if you give the verification, let's see what happens. Initially your compilation will be given closed. Okay, so let's verify this file, verify this code. So you can see only 2 lines are, the output, that it is verified. Okay, done compiling. So compiling and verification is done, which means there is no error inside your code, but you don't know the directory where you can find the hex file. Okay, so what can be done, you will just go to file again and enable the verbose. Okay, this verbose output has to be enabled. And how that can be enabled, since we are doing simulation, we will not select this upload one. Okay, if you select this upload option, then you need to add one hardware system with your coding. But now since we are doing in software, which means proteus only, we are not going to deal with hardware for today, so we will just give OK. So now if you give this compiling, okay, verify, and you can see many lines are coming, verbose operation. Okay, so now the compilation is done. Let's see if we can see what is happening inside this compilation operation. So you can go through all the lines and find where the hex file is being stored. So for that, what will happen, you need to scroll this page a little bit using the scroll selection tab that you have, okay, bar that you have. So if you scroll here, see this line right here. Okay, if I select this, let's select this line right here. This is the location where your hex file has been stored. So since I know where the hex file is being stored already, so I will just go to my file, go to the proteus, and if you select, this is the folder, so just I will select the folder, hex file has been generated. So if you relate the name was sketch25.ino.hex. Okay, so after that just give OK, and if you just play your system, and you can see A, B, C, this will just go on, because the time I have given is, I have increased the time delay. If you want to decrease the time delay, you can just modify it in which part of your code, actually in this part. Okay, instead of 1000, let's say I am going to take 100. Okay, so if I take 100 and then verify it again, and it will be stored somewhere, the hex file. Okay, so next I can again, okay, I need to stop the simulation first. Then if I add the file, that where the hex file has been generated, so you can see the date is not correct, so I need to search where the hex file has been generated. Okay, so today is 27th in my clock, but it is nowhere nearby, so I need to search it, that where it is actually being stored. So the date is 27th, I need to find it, I need to search it where it's being stored. So it's usually is in C drive. You can see the users folder is not available here. So what can I do? How can I help myself? So I will use WinRAR for finding it. Okay, so where is my WinRAR? I can go to the desktop for my help. Okay, so I am going to desktop, and I'm going to select all files. No, it's not available here, so I need to go back to the main. Okay, I can search in here, WinRAR. Okay, so I'll just go there. So if you don't file the C drive and if you are facing any problem with that. So I can search it in here, so you can see stored somewhere. So August 25A, so it is 128.868. Okay, this part right here. So again I will go there. This is basically one, yeah, this one. So just see the time in 27th. Okay, this is the time. It is around PM, so 4 something PM. So I will just search this file right here, and I can just copy it and place it in whichever file I want. Let's say I want to place it in C drive. Okay, in this folder most probably. Okay, anywhere here. So just drag it and place it. So here is your file. So just go to the Proteus and go to this C drive that you have, and I need to search it inside this folder so you can see the updated one. You can see the time as well. So just open and place OK, and now it will run. The drastic changes will happen. So you can see A is showing, B, C, small c. Okay, it is more faster than the previous value, right? Previous transition, it was taking from transitioning from one first alphabet to the second alphabet, it was taking more amount of time. So those who don't have problem with C drives, you can already go to the users section and then just follow the directory. Okay, which directory? The directory that will be found after compiling. Okay, users, then inside one folder, maybe app data, local temp, etc, etc, etc. So if you don't find this from your C drive directly, you can use this WinRAR one. This is one another very popular thing that you can use for zipping any file. Okay, so this is very common. Many of us usually do use this zip file software actually. Okay, WinRAR software, we do use it very often. So anyways, this is how up to S your total output will show. So now, since you already know how to display one 7-segment operation, okay, display an array of different alphabets, you can also try with odd numbers, odd digits, even digits. You can try different options, like maybe instead of showing alphabets, maybe digits only. Maybe you can use these orientations in cascaded format as well. So totally depends on you. I hope that this video has been useful for your for doing some other projects. This is just the basic. You can use this code also, so just you can go through the whole video. And thank you very much for being with me for such a long time. So take care, and I'm just stopping the simulation, stopping this video for now. Okay, ending this video. Take care everyone. See you until the next video. See you in some other class. So thank you very much.